Hello and welcome to the review for exam 2. So we already went through the topics and we had office hours twice. There will be another chance for office hours on Friday before the exam is due, right? Friday I will be online in the evening around 9:30 on Microsoft Teams. All you need to do is to find that email with invitation to join the team, and at the scheduled times just join the meeting. Well, given that today is the review, I'm expecting a whole bunch of people to show up, so with questions. I did answer a lot of questions during office hours, but maybe there are some extra questions, things to work with. So I will, work out some standard problems, standard stuff, and then if you have any questions, just post them in chat. We already covered the list and we know everything that is going to be on the test. So add 3 plus 2i, right, plus negative 6 plus I. We will do that with like terms. So 3 minus 6 is actually negative 3 plus 3i. So real. Why? No, exam is not tonight. I see the chat question. Why would you say exam is tonight? Today is only a quiz. Let me check my MATLAB and see what is going on. There is not supposed to be any exams on... your exam should be on Canvas. I'm going to check this real quick. Exam is on Canvas. What is going on here? There's supposed to be a quiz, and that's it. Assignment manager. What is this thing? Yep, there was something, I don't know what that was. Maybe the old exams from previous. Your exam is going to be on Canvas starting Friday, Saturday, Sunday, as we discussed here. So I will have to make a quick post on Canvas regarding this, whatever the thing was. Let's see. Exam 2. Is this pre-calculus course? Yes. Okay, announcement. All right. Okay. Just give me 1 second to make it clear. So Friday 4/17. Saturday 4/18. Sunday 4/19. Close at noon. There we go. That's it. So you have the dates, you have the days, you have the closure time at noon on Sunday. I'll add extra half a day, so that's free of charge. All right, cool. And I'll let you. So this will. I don't want to mention at all MyMATLAB in this thing because it was some kind of a glitch. Not sure what that was. But it's gone now. Good. Alright, so that's posted. Okay, so no exam on MML, just quizzes. That's it. Okay. So now that we have all of this, let's go and take a look. So I added some complex numbers. The practice exam is under exams in MyMATLAB. So you go quizzes and tests and you scroll down, it will say sample exam or something like that. But maybe I can open this thing and call it practice exam, whatever. So now I see evaluate x squared plus 19 divided by 6 minus x for x equals 4i. So x, oops. Evaluate x squared plus 19 divided by 6 minus x for x equals 4i. So what we need to do is we plug in the values in for x. So we have 4i squared plus 19 divided by 6 minus 4i. When I square, I get 16i squared plus 19 divided by 6 minus 4i. I squared is -1, so we replace that. We get -16 plus 19 divided by 6 minus 4i. This is equal to 3 over 6 minus 4i. Now, we cannot leave it this way, because we have a complex number in denominator. Complex number means I is the square root of -1. We're not allowed to leave roots in denominator, so we have to rationalize this using the conjugate. Come on, there we go. So we'll multiply by the conjugate to get rid of the complex number from the denominator, and we will have 18 plus 12i and denominator is going to be 6 times 6 is 36. The middle terms will cancel, and you will get 14, so minus 16i squared. This is going to be 18 plus 12i divided by 36 plus 16, because again I squared is negative 1. This gives us 18 plus 12i divided by 52. And now we have to write it as a complex number, which is 18 over 52 plus 12 over 52 I. And then we reduce each fraction as far as we can. So 52 is divisible by 2. That will give us 9 over 26. And that has no further cancellations. And then 12, that's 6 over 20. We can cancel by 4, so that's 3 over 13i. So if you are using MyMATLAB, this is the number you need to plug in, because that's the number that does not have square root in denominator, which is this. So if you got up to here and left it, it marks it wrong because it's not complete. It's not wrong. It's just it's not wrong. It's just incomplete. You are leaving the square root in denominator, and that's not good. The next mistake is people leave it here, but this form is not a plus bi. You see, it's not clearly separated into a plus bi. So that's why this is the form that should always be presented, right? Because that's the form of the complex number. So we went from plugging in numbers and computing to technically rationalizing to get square root out of the denominator. And once we got the square root out of the denominator, we split into two fractions so we can have the form of a plus bi, which is what is required. For I, how is it negative 16? It's negative 4i times positive 4i is negative 16i squared. And then I squared is positive 1, so it changes it into negative 1, so it changes it to plus. Negative 4i times positive 4i is negative 16. Oh, on the numerator, yeah, 4 times 4. 4 times 4 is 16. I squared. Then I squared is negative 1, so negative 16. So I hope this makes sense. All right, let's see. Any questions, including if you have anything on MyMATLAB, if you found anything that it's Well, the good thing is that we don't have to worry about MyMATLAB because it's not going to be MyMATLAB for exam, so I will be able to take a look at your answers and make sure everything. All right, so I see two questions on quadratic formula, and quadratic formula is used when we have a situation that we cannot factor. So you can have quadratic formula pop up anywhere, right? You can have it literally pop up anywhere. And what I'm going to do now is I'm going to collect my A, B, and C. Well, first of all, what I can have is x to be real repeated, or complex. So those are the possibilities. You can calculate what is called the discriminant and check which type of these. This is discriminant bigger than 0, discriminant equal to 0, discriminant smaller than 0. And discriminant is the thing under the square root. So by computing the discriminant, which is 11 squared minus 4 times 3 times negative 9, we'll get 121 plus 27 times 4, that's 80, 28, 108. And that's larger than 0, I don't care. So I'll have 2 roots. Okay, so I'm going to change this into a plus over here. And that should give me complex answers, right? Because there will be a plus here. No, it's still not a complex answer. This 11 is going to be now 8. Let's see. It's going to be 8. That's going to be 64. I'm making a problem because if you have a specific problem, just type it in and then I can work with that. So 9 times 3 is 27. That's 80 plus 28, right? $108, and it will be a negative number there. Good. So now it becomes complex. Okay, good. So if this is a problem, it will become complex problem because it's complex because the discriminant is less than 0. That means that you are going to have a negative number under the square root. So A is 3, B is 8, C is 9. We feed that into negative b plus minus square root of b squared minus 4ac over 2a. And we get negative 8 plus minus square root of b squared is 64 minus 4 times a is 3 times c is 9 divided by 2 times 3. So we just plug values in and then like good luck with rest, which is arithmetic. Negative 8 plus minus square root of 64 minus 108 divided by 6. This is negative 8 plus minus square root of, the difference is 44 divided by 6, negative 44. So I have negative 8 plus minus two square root of 11 I over 6. So how to get 2 square root of 11i? Well, square root of negative 44 can be written as the square root of negative 1 times 4 times 11. When you decompose it over the numbers you can take roots of. Square root of negative 1 is I, square root of 4 is 2, and square root of 11 you can't take, right? I mean, you can get the decimals, but no one cares. So, it's negative 8 plus minus 2 root 11 I over, and each one of these gets over 6. So, the first one is negative 4/3 plus minus root 11 over 3 I. And there they are. You have a plus and minus, which means it's a complex conjugate pair, which means, right, one each. So we need to find one more of these guys. Just have to dig up the textbook real quick. There we go. Trying to find another one of these polynomials with where is the quadratic function? There we go. So quadratic formula that will have square roots. You said radicals in the answer. Oh, great. All of the answers are somewhere else. Okay, so we need 2. Give me 1 second, I just need to find a problem that will fit nicely. Exercises 2. Exercises 2, 3. What quadratic function is not in 2? It has to be in 2-5. If it's not, okay, 2, ooh, yes. Alright, 2-5, looking good, looking good. So 2-5. And we are supposed to look at the problem 14 apparently looks good. Wait, why is this exercise is 2-5 doesn't match the solution on 2-5? This is absolutely crazy. It gives me two different solutions. Exercise 14. Exercise 14. Oh, part C is the one that is not listed. Okay, good. All right, so 2.5, exercise 14 is the one that would have what you need. So this is 2x cubed plus x squared minus 3x plus 1. Oh, great. I spent all this time and now I see problem in the chat. So, well, it's going to be the same, solved the same way. So we're going to go with the PRs, possible rational zeros. Those are factors of 1 divided by factors of 2, which is plus minus 1 and plus minus 1/2. So that's All right, cool. So now we have only 4 numbers to check. We are trying to find all roots, right? Find all roots, also known as zeros, depending on what the software said. Find all roots or find all zeros. So what do I have? I have f of 1. That's 2 plus 1 minus 3 plus 1 equals to 1, different than 0, no bueno. Negative 1. That's 2 times negative 1 cubed plus negative 1 squared minus 3 times negative 1 plus 1. And when you do this, you get negative 2 plus 1 plus 3 plus 1. Still can't be 0 because way too many positive numbers. Okay, so f of 1/2. 2 times 1/2 cubed plus 1/2 squared minus 3 times 1/2 plus 1 is 2 times 1/8 plus 1/4 minus 3/2 plus 1. That's 1/4. Oh, it works! Nice! That's 1/4 plus 1/4 minus 3/2 plus 1. Look at this. That's a half minus 3/2 plus 1 is negative 1 plus 1 equals 0. Yes, we got it. So positive half. So x equals half is a root, which means that x minus 1/2 is a factor. Cool. So now we do our synthetic division with a half. Our coefficients are 2, 1, and negative 3, and 1. So we drop down the number, which is 2, times a half. 2 times a half is 1. When you add them, you get a 2. 2 times a half is again 1. When you add them, you get negative 2. And then negative 2 times this is negative 1, giving you the 0 you need. We already know it's 0. We got it up there, but we needed this. So now this is leaving us with 2x squared plus 2x minus 2 equal to 0. And you can even reduce this by 2, because they're all divisible by 2, into x squared plus x minus 1 equal to 0. So now we take the quadratic formula, negative b plus minus square root of b squared minus 4 times a times c divided by 2a. That's negative 1 plus minus square root of 1 minus is a plus over here, and that's a 4 divided by 2, and it gives us negative 1 plus minus root 5 over 2. And this cannot be reduced anymore. That's it. I mean, yeah, you can go get the decimals, but generally no one cares. So what are the roots? Roots x equals half, x equals negative 1 plus root 5 over 2, and x equals negative 1 minus root 5 over 2. What is the factored problem? It's x minus 1/2, x minus negative 1 plus root 5 over 2, and x minus negative 1 minus root 5 over 2. And I just fix these signs because it really looks disgusting there. So x minus a half is x. You distribute the negative in, so plus, and then it's 1 minus root 5 over 2. And you distribute the negative also, so it becomes a plus. 1 plus root 5 over 2. So I don't know if my MATLAB is sensitive to to which of the two factors you get to write, but the one on the bottom is good. Doesn't have like million negative signs, you know. So it's better. Ooh, really cool problem. Let's take a look at that one. You can go over this problem, I don't think. Let's see. Y varies directly as x. So y is proportional to x. And then it says, and inversely with a square of z. Y is 12 when x is 64 and z is 4. Find y when x is 68 and z is 2. Alright, so this problem is just a little bit of fun running around. Y is proportional to x is good old y equals kx. It's a proportionality formula. And over here, y is also proportional, but inversely proportional. So let's use m over z squared. We use the first set of values to figure out k and m, and then we can just calculate y quickly. So y, which is 12, is equal to k times x, which is 64. So k is 12 over 64. Both of these numbers are divisible by 4, so that's 3 over 26. Is it 26? When you divide, no, 16. So 4 into 6 goes once, and then 24 goes 6. Okay, good. So we found our first equation. Y equals 3x over 16. You can immediately plug 68 over here and calculate your y. Not even sure why we have the z involved. It's probably some random question somewhere. This is not even pre-calculus. This is from intermediate algebra question. Proportionality and inverse proportionality. So this is from intermediate algebra. You can also plug in y is equal to 12 and then divided by m over 16 and calculate, the m value. So it was somewhere. I'm not sure where I found it, but that's what it is. So now we know x equals 68, plug in, and you get your y equals 3 times 68 divided by 16. Yeah, sometimes they sneak some stuff from. You won't have anything like that on that. Is Canvas have a keyboard to plug those powers? Oh, you mean the toolbar? I don't think so. I'll have to read what you typed. It's going to be interesting grading it. Any other questions, concerns? Yes, that would be x to the fifth. I know, poor eyes, right? Poor my eyes. Aha! F of x is equal to 3x squared minus x cubed. Find zeros, y-intercept, determinant behavior of the graph. All right, so how about get everything? Not just the things you listed, but get everything. All right, so let's just do the whole problem. All right, cool. So we start this problem by looking for x and y intercept. That's the fastest and easiest. Well, actually, domain is the best. This is a polynomial, so domain is all real numbers instantly. And then for the x-intercept, set y equal to 0. So we have 3x squared minus x cubed equal to 0. We factor out x squared, we have 3 minus x equal to 0. Whereas x equals 0, multiplicity 2, and x equals to 3 with multiplicity 1. So your x-intercepts are 0, 0. And 3, 0. Now, when you have a 0, 0, that's immediately your y-intercept as well. Set x equal to 0, you'll just have 3 times 0 squared minus 0 cubed equal to 0. So, as I said, 0, 0. So we have domain, x-intercept, y-intercept. Polynomial functions do not have any asymptotes. So logarithmic functions have them, exponential functions have them, rational functions have them. But the square root functions and the polynomial functions, they do not have asymptotes. Okay, and the next is to work on our graph and all of that stuff. So now f of x was given as 3x squared minus x cubed. So now, what you do is you first write this as negative x cubed plus 3x squared, because you need that leading term. You need that leading term. Now that you have the leading term, you know that your a is less than 0. And you know that your exponent is odd. So that will give you this type of end behavior. So that's what's important. So we have 3x squared minus x cubed, and we have this as the right. So now what we do is we draw the graph and put all of the intercepts. We don't have any asymptotes, so we don't have to worry about that. So that's our x-axis, that's our y-axis. We have 0, 0. And we had at 3, right? Yes, at 3. So 1, 2, 3. And we have the end behavior, which looks like this, because we memorized, right, the chart of 4 possibilities, right? You know the one with the a less than 0, a bigger than 0, even and odd, right? So they had four different things to, so that's the leading term chart. So what we do is we know that our 0, 0 is the M2 root. 0, 0 is the M2 root. By the way, x-intercept, root, and 0, those are all the same concepts, right? So be careful about that. So this has to bounce off of the 0 because it was M2. And then it has to connect straight through 3 because it's M1 root. It has to shoot straight through and connect into the other one, which is perfect. And connect into the other end behavior. And immediately check this, right? Make sure that it looks somewhat decent. That's it. That's all it is. So I hope this is good enough. We did everything. We did not have to, luckily, factor much and do a lot of those things. Descartes' rule of signs. Oh yeah. So Descartes' rule of signs is one of those quality of life situations, because it tells you how many positive or how many negative possible real zeros you may have. So, and you look at the number of sign changes. So if you have, let's say, x to the 4th minus x cubed plus 2x squared minus 4x minus 8 equal to 0. You want to find all, right? Find all roots, zeros. Find, I'll just put it here, roots. Also known as zeros. You can also say x-intercepts, whatever. Descartes' rule of signs would not be something that you want to use here, because you have a lot of sign changes. Look at the pairs. Pairs is factors of 8, plus minus 1, plus minus 2, plus minus 4, plus minus 8, divided by plus minus 1 coefficient of x to the 4th. So your list contains 8 numbers, and they're all cheap to compute. Now look at the number of sign changes. 1, 2, 3 sign changes. 3 sign changes say that we have at most 3 positive real roots. But I only have 4 positive numbers to check, so I'm not saving much in life, right? If I had 16 numbers to check, or 25 numbers to check that are positive, in that case, as soon as I find the first 3 positive, I don't have to check anymore. This is not guarantee. This is something that is there, you know, if we can use it. Let me see if I can find. So if you have a problem that has all same signs or just one sign change, well, in that case, yeah, it's really, really useful. But Descartes' rule of signs, or something that has a lot of changes or relatively small amount of numbers to check, is not something that we would use. So we use it only for problems where it's really helpful. Oh, here is a really helpful problem to use Descartes' rule of signs. Well, not so much. They gave us really low numbers. Can I find one example that it's worthy of this rule? What is going on over here? Problem 45 is a good one. But its answers are bad. You don't get to see the rule at work because the answers are bad. See, for problem 45 on page 378, you can have at most one positive, because there's only one sign change. You can have at most one positive real root, but turned out you have none of them. So whatever. You would still check all of the positive numbers and you wouldn't find anything, and then you would move to the negative numbers. The trick is to actually use the rule, and then you stop checking the other numbers because rule said you can't have more than this. That's the reason why we would actually have the rule. Trying to find a good example, it's just there are no good examples. Alright, so here is, well, let's just do one of these. So here, 34, f of x is given as x cubed plus 7x squared plus x plus 7. And yep, 7x plus 7, good. So how many sign changes? No sign changes. That means no positive real roots. And that's very helpful, because I don't have to check any positive numbers. I know it's a really lame example because it has a 7 there. Actually, we can make this problem much better. Here, kill this. 12. You can make it even worse with 24 over there. So I just made this problem work, right, because I have a 12 there. So what are the pers? Plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, plus minus 12, divided by plus minus 1, which is technically only the numbers on top. How many numbers do I have to check for the roots? 2, 4, 6, 8, right? So I have to check 12 numbers, because I have positive and negative 1, positive and negative 2, positive and negative 3. But the Descartes rule of signs said, oh, no sign changes. Well, you don't have any positive roots. So now, when I go and I start my f of x calculation, right, when I start plugging this, I just go with negative 1. I mean, this problem can be solved by algebra easily. We're not supposed to do this pre-calc stuff, because this is just x cubed plus x grouped plus factor out 12x plus 1, and this is x squared. When you factor out x squared, you have x plus 1 plus 12 x plus 1, right? And you will get x squared plus 12 x plus 1. This is basic algebra problem that we solve quickly by factoring. But we can also, you know, plow through using pre-calc. So you plug in -1 and you see if -1 works. That's -1 plus 12 minus 1 plus 12. Nope. Then you try -2 and you get what do you get? You get -8 plus 48 minus 2 plus 12. Nope. And then you try 3 and so on, and you see that -12 will be the one that works. But look, -12 would be the last number you check after you check all of the positives and all of the negatives, right? That will be literally your 12th calculation. But because you know the Descartes rule of signs, you did not check any positive numbers because the rule said you can't have any positive numbers. Therefore, you reduced your amount of calculations down to 6, because you would find that root at -12, you would find that all the way, or whatever the root was. Oh wait, it was supposed to be -1 root. When I factor, right, I get x cubed. Yeah, it was supposed. Why is my -1 not working? I'm confused now. X cubed plus x plus group x squared with the 12. When I factor out x, all of the roots are complex. All of the roots are complex. See that? Because this is x squared plus 1. Over here there is a 12 in front. Now you kick out 12. You get x squared plus 1. And no, there is a root. I was right. There it is. I can't have all roots to be complex. This is odd. So x equals 12 and x equals plus minus I. 3 roots. Good. So eventually over here we would get f of -12, and that would be -12 cubed plus 12 times -12 squared plus -12 and then plus 12. And you can see that negative dies because of the square. So these would cancel, and then these would cancel. You would get a 0, and that tells you that x equals -12 is a root, which gives you x plus 12 to be a factor, which is right there. I didn't write -12. There we go. What a confusion of the problem for no reason. We can solve it by algebra. But that's the story of Descartes' rule of signs. It is the quality of life theorem. If you don't know it, you're just going to spend a little bit more time than others computing everything. Possibly, but that's life. You spend time to learn something, and then you have to waste less energy doing it, right? Which is why it's important to listen to experienced people, because we all want to be lazy, so we find the least right, the way that takes least amount of energy. All right, is there anything else that you would like to discuss? I will mention one more time, office hours 9:30 p.m. on Friday, 9:30 p.m. Microsoft Teams, you all have the email. Can you go over holes when graphing? No, you would fall in. As you're walking on the line, if there is a hole, just fall in. Yes, so anytime when you have a rational function to graph, if it cancels, it will create a hole in a graph. So if I have f of x given, so graph, and you have x squared plus 6x minus, kill me now. Give me 1 second, I have to compute this stuff now in my head. I think of a number and then I lose it, and I think of a number and I lose it, so give me a second. So I think I can put 55, right? So I think that would be good. And then I can put x plus 11 over here. So what do I have? What do I have here now? I have a problem which looks like it has the vertical asymptote, but it doesn't. I know that you can set x plus 11 to 0 and get negative 11. But the trick is that the numerator will actually factor to x plus 11 x minus 5 divided by x plus 11. See, that gets you negative 5 and positive 6. And then these two cancel, so technically what you are graphing is a linear line x minus 5. But you have to put open circle at negative 11. So this is y equal mx plus b graph with hole at x equals negative 11. So when the denominator cancels, it has a hole at that value. If the denominator doesn't cancel, it has a vertical asymptote at that value. Much more on that when you take Calc 1. We have a whole section that talks about vertical asymptotes and defining them through limits and so on. So now if I am to graph this problem, I will actually have to do this because I need negative 11. So we'll have 1, 2, 3, 4, 1, 2, 3, 4, negative 5. And then that would go at 45-degree angle because the slope is 1. But at negative 11, we're going to have open circle 4, 5, 6, 7, 8, 9, 10, 11. So whatever it intersects this line. So I have my 45-degree line. Goes forever. But on this side, when it hits negative 11, there is open circle at negative 11. So open circles for whatever type of function you have. If the denominator cancels, there is no vertical asymptote, so you would have an open circle. Okay, next. Is the question on HK, which is the standard form. Quadratic, y equals a, x minus h squared plus k. This formula is the best formula in the galaxy for graphing quadratics, because HK is the vertex, which is min or a max, and A is either larger than 0, which means opens up, or less than 0, which means opens down. So we have nothing to compute. If we have this form given, we just draw the graph instantly. So if it's given to us that y is equal to negative 3x plus 1 squared minus 2, all you need to do is to collect your numbers. Your a is less than 0, it means we will open down. And your h and k are negative 1 and negative 2. Be very careful. Right? The formula has a minus sign. So when you have a minus sign here, this value is positive. So be very careful about that. And I just need to graph this. So it's literally a second to graph these things. Negative 1, negative 2. Opens downwards. We're done. Nothing to compute, right? You just look at the values. This is equivalent to graphing y equal mx plus b. Oh, I can't do that now because it's set up for exam. It will mess something up. It'll be fine. Oh my god, it's just you're stressing too much. You are stressing too much. Let's do some other problems. I know. Panic. Woohoo! Oh, look at that. Boss, x to the 4th minus 4x cubed minus 5x squared plus 16x plus 4 equals 0. You started typing this yesterday, right? It's finally here. All right, so here we go. We are going to, I guess, question is to find roots. We can draw sketch the graph. So, roots, graph. So, what do? I get the, domain for all polynomials is always negative infinity to positive infinity. Range, we're going to take a look once we graph it. The number of sign changes here. Yes, we're going to do the prs. Yep. Number of sign changes is a lot for the prs, because the prs is going to give us factors of 4. Well, that's plus minus 1, plus minus 2, plus minus 4, divided by plus minus 1. We only have 6 numbers to play with. and the number of sign changes, so only 3 positive, right? Number of sign changes is 1, 2. So since I have 2 sign changes, that means that I can have 0, 1, or 2 positive real roots. Well, yeah, plus 1, right? it won't change much in life. Anyway, so that's that's pers. So we go f of 1 immediately, which will give us 1 minus 4 minus 5 plus 16 plus 4. These guys cancel. That's not a 0. So we drop 1. You know, I'm going to try negative 1. Easy calculations first. So that's becoming 1 plus 4 minus 5 minus 16 plus 4. Nope. This 16 is really overpowering here. Let's see what happens when we use 2. F of 2. So now we have a 16 minus 32 minus 20 plus 32 plus 4. I hope. And that's 0. Woo! So we got our first 0. 2 is a root. X minus 2 is a factor. If you are supposed to write factored form at the end, you need the collection of all of these factors. As soon as I find a root, I do synthetic division. So what are my coefficients? 1, negative 4, negative 5, 16, and 4. Bingo! Yeah, right. So now, drop 1 down times 2 gives us negative 2. Times 2 gives us negative 4, which makes negative 9. Times 2 gives us negative 18, gives us negative 2, gives us negative 4, gives us 0. Yay! New problem is x cubed minus 2x squared minus 9 minus 9x minus 2. Continue with the list. All I can check now is a negative 2 value. So how about f of negative 2? That's negative 2 cubed minus 2 times negative 2 squared minus 9 times negative 2 minus 2. That's negative 8 minus 8 plus 18 minus, bingo! There's another one. Negative 2 is a root. X plus 2 is a factor. Negative 2. 1. Negative 2. Negative 9. Negative 2. Is it okay to start with synthetic division? Yes, if you are faster, why not? Right? Your synthetic division will not get you zeros there. So once you hit the 0 there, you know you stop. Negative 2 gives us negative 4. Positive 8 gives us negative 1. Gives us positive 2. Gives us 0. Great. So now we have our x squared minus 4x minus 1 equal to 0. And we crank negative b, that's a 4, plus minus square root of that's a 16, minus 4 times negative 1, positive 1, divided by 2a, which is 1. Good, which is 2. Right, so that gives us 4 plus minus square root, and then this is a square root of 20 divided by 2. That's 4 plus minus 2 root 5 over 2. Because your 20 can be written as 4 times 5. Square root of 4 is 2 and root 5 stays under. Now, what are they asking for? Are they asking for roots? Okay, you provide roots. Zeros, whatever. X equals negative 2, x equals 2, x equals, cancel by 2, 2 plus root 5, x equals 2 minus root 5. Are they asking for factors? Well, that's x plus 2, x minus 2, x minus 2 minus root 5, x minus 2 plus root 5. You just need to know what is the question, right, is asking for. And once you know that they're asking for roots, you provide list of roots. If they're asking for list of factors, you multiply all those factors, because if you are to FOIL all of this mess, if you are to FOIL all of this mess here, it will give you back the original x to the 4th equation with a plus 4 at the end. Anything else? I wonder if Rock is in the right class. Because I don't know why it just comes up with another. I remember the last question you asked with the proportion, it was the algebra question. And this one is also algebra question. Are you looking at the same exams as everyone else? Because look, you have 11x to the 4 minus 8x cubed plus 10x squared divided by 4x cubed. How's this on my MATLAB quizzes? What's wrong with this software? This has nothing to do with pre-calc. This is elementary algebra. This is 11 over 4x minus 2 plus 5 over 2x. You cancel, right, each exponent, they just subtract. This has nothing to do with pre-calc, right? You would have to have a long division of polynomials, like minus 1 over here or something, so we can do the long division of polynomials. But this is just canceling powers. If it is x minus 4, then it's a completely different ballgame. 11x to the 4 minus 8x cubed plus 10x squared divided by x minus 4. In this case, it's a long division. And you can do that either by synthetic division, 4 into 11, negative 8, 10, 0 for x and 0 for constant. Or you can do it, because this is linear, right? You can do synthetic. If this was x squared or something, you can do synthetic. So you drop down 11. 11 times it gives us 44. 44 minus 8 is 36. 36 times 4, holy nightmare. Terrible. 120, 144. Add them up to 154. And then times 4, that's 400 and 216, 616. So that's 616. And then 616 times 4. That's 2400. And then 1664. So 2464. And it's just terrible values, but that would be a pre-cal question. But the previous one was definitely algebra, where you just cancel the powers. Yeah, I'll have to check why my MATLAB glitched. I hope that it didn't glitch out to the point where it gave you only algebra questions. Because this stuff, I mean, you had this class a year ago or less, but still, you could have had a nice pre-cal question instead of a question wasted on algebra. That's okay. I mean, I solved both of them. You know, the original question that was posed, and your version of changed question. I answered both of them. It's just I'm worried what's happening with my MATLAB. That's the only thing. All right. Anything else? We have a couple of more minutes. Any suggestion example from you? I don't. It's a whole bunch of stuff. I think we covered everything. We talked about complex, we talked about roots, we talked about graphing, we talked about the leading term coefficient, we did the long division, synthetic division, we found the prs, we did the Descartes rule of signs, we talked about the asymptotes. There was that cool question with the hole in it. I mean, we are technically talking about 5 sections for the exam. A word problem from 110. Now we're talking. There are a whole bunch of word problems in 110. I don't even know which one. Do you, if you have a question number, that will be the best. I'll wait another minute or so, and then I guess just pick one and go from there. You can take one. No, I can't, because then I have to swap it. Alright, let's see something cool. Problem 32 is cool. So this is 110. Yeah, 110 is on the test because we don't have the chapter 2 is really lame. Has no word problems or anything like that. It's just really, really bad. Word problems are the only thing that make you money. So we'll have really cool stuff to make up, right? In chapter 3.5, it's all word problems. So like one of the best word problems in all of mathematics are in chapter 3.5. But chapter 2 is really kind of dull. It has no word problems almost at all. So we just added Yeah. So this one has, problem 32 has this really cool box that we can construct. You can actually make this out of paper and then verify all of these things. So we're going to have a box. And this box is going to have a divider inside. There we go. So this is going to be x and the height is going to be y. So the figure shows an open box with a square base. So square base, that's x as well. And it's to have 400 cubic inches of the volume. There we go. So find the area of the material, right? How much material do we have to use? Area of the material. So this is going to be paper, cardboard, whatever. Okay. Well, this is material here. This is the material as well. This is the material. This is the material right there. That one, and obviously the floor. So what is the area? Well, I have the floor, that's x squared. We can also call it bottom. Then we have plus, and I have 5 xy's to go around. Each wall is x times y because the height is y everywhere, right? So x times y everywhere, including the middle, right, is x times y. So we have 5 of those. Now, what is my volume? Volume is the base times the height. And that's 400. They only want you to write the formula, nothing else. So, very simple. Y is equal to 400 over x squared. Plug in. And done. So A is equal to x squared plus 5x, and you have 400 over x squared. So A is equal to x squared. One of the x's will cancel. And you have 2000 over x. That's it. 2000 over x. So this is area as a function of the size of the box. So if you want to make this out of cardboard or so on, right, and you have a certain amount of area of the cardboard, you can play with numbers in this formula to figure out what is the largest box. Because remember, dimension x, it gives you the dimensions of the base of the box. So if you have some kind of cardboard like this, you can't say, okay, well, I'm going to use the whole cardboard for the box, for the base. Then you don't have enough material to make the sides. You can't even say, oh, I'm just going to fold this in, because if you fold that in, then you don't have enough for the middle, right? So it's a little bit more engineering than just, going at it at the first shot. So that's the word problem, random word problem from section. They're all the same. You have the farmer, you have the tickets, and you know, all that stuff. All right, troops. So keep practicing, work on the quizzes. You can go to study plan to practice anything you want in MyMathLab. If it's not open, if you missed some of the homework or whatever, just go to study plan. Everything is available 24/7. The next office hours are scheduled for Friday. What is the Friday? Is 19th? 17th? What is the Friday? Friday 17th. So Friday 4/17, 9:30 p.m. For office hours. If you have any further questions, the exam starts on this day, and then you can take it on Saturday or Sunday morning. It should close at midnight on Sunday, so, sorry, not midnight, noon, Sunday noon, there we go, noon. So that's the exam, but this is for office hours over here. So I will see you around. Keep practicing. Bye.